Good afternoon, everybody. It's a pleasure to be here at Strata. I'm enjoying myself, learning a lot. This is, in fact, my first O'Reilly conference. Actually, it's my second. I was here at Jumpstart yesterday, which was also really awesome. It's a pleasure. The theme is big data. And I don't want to be a downer, but I'm here to tell you that big data just doesn't cut it. You're not doing it right unless you do big, bad, bodacious, butt-kicking data. Okay, I'm a big-ass analyst, so I know what I'm talking about. So I'm James Kobielus of Forrester, and waiting for the slide to advance. Here we go. So I'm here to talk about, to some degree, the downside of big data. We often talk about big data as being an asset, a business asset, and it certainly is, but can also be a significant liability. Well, maybe not in an accounting sense. It can be a significant burden or problem if you don't manage it right. It's expensive to store all that data and to process it. It can be difficult to sift through it and find the nuggets of intelligence you need. So that's why I've titled this, and nobody take offense here, I'm not addressing anybody in particular here. Big data, keep it small, stupid. What I'll be discussing is how, in fact, you can manage your big data initiatives in a way to keep the cost down and to improve your business intelligence and analytics. Keep it small, stupid, while making your business smarter. Fundamentally, big data is a burden, or can be. Petabytes worth of storage. You know how much that costs? Well, I have some numbers later on. It's not cheap. And so you don't necessarily want to hold on to every datum from every source going back, to the dawn of creation. Clearly, you gotta sift and sort and curate and purge and so forth to keep it all manageable and keep your storage budget from going through the roof. As I said, your storage budget could go through the roof if you don't keep your data compacted, compressed, and storage efficient. Keep it small, but no smaller than possible or practical. Just as critical, your users need access to that data. Your applications need access to that data. And I don't know about you, but I personally don't relish the thought of navigating through petabytes worth of unstructured, semi-structured, and all this data that's coming from everywhere. It's not organized. So you need to make sure that you're providing intelligence to the applications and users and devices, including tablets and smartphones in your business intelligence environment, to help real people make real decisions to run your business. So keep it small, stupid. Keep it compact and consumable, your data. So today, I'll be discussing what is big data, and I'll try to skim over the low-level technical plumbing. It can get pretty involved, and I don't want to bore you. It's late in the afternoon. And then I'll be discussing the magnitude of the big data problem, how big it's getting, and how soon. I'll provide you with some practical guidance on how to keep it small, compact, and consumable without compromising or inhibiting your big data analytics initiatives. You can manage more data, or should be, more efficiently and more rapidly and more consistently if you follow the high-level guidelines I'll be providing today. And then I'll provide some future trends. If you don't fall asleep during the foregoing presentation, I'll provide some real forward-looking, visionary, futuristic prognostications about how big data will get real small and be everywhere, including especially in every consumer device. Or as Steve Martin once said, keep it small, or let's get small, but in a different context, because we are all getting small real soon. So big data, what is it? On one level, it's just a big overstuffed, bursting paradigm that clearly is everywhere and is the theme here, and it's one of my core themes at Forrester Research in terms of my ongoing coverage of a lot of different data and analytics topics. We often break it into the 4 V's of big data. There's the dimensions: volume, more and more data; velocity, it's coming in faster in real time; variety, a huge variety of data ranging from relational data to unstructured text to what's called semi-structured documents like extensible markup language. Huge variety and a huge variability. Some days you need to process a boatload of structured data. Some days, some hours you need to process a boatload of unstructured data coming in from Twitter and Facebook and driving it into your marketing initiatives. There's a variability there. So fundamentally, big data is a lot of big business initiatives, and it's a lot of big investments in the enabling technology. And fundamentally, big data is to serve decision makers, information workers, your data scientists, to help them find patterns, intelligence to run the business on. So at a very high level, when we talk about data scientists, who are in many ways at the forefront of the big data paradigm, what do they do? What does big data as an approach enable them to do? Well, fundamentally, big data, however implemented through a massively parallel enterprise data warehouse or through a Hadoop cluster or some other approach, the paradigm, there are new things going on here. You can keep the entire population of relevant data at your fingertips and do all kind of fancy data mining, sentiment analysis, and the like on it, rather than keep, as is the standard practice, convenience subsets or samples of that data. You have all the data at your disposal potentially, and what I call, you can unify all analytic time horizons. You can have historical data. You can have real-time data streaming in from various sources on the social web or from in your operations. And you can do predictive analysis on all that data, so you can do some seriously heavy-hitting and versatile analytics to drive many types of decisions. You can do more powerful business applications, more powerful long-tail analysis to look for micro segments. So you can target offers, what are often called next best actions or next best offers, into a broader range of downstream marketing, sales, customer service, and other environments, and optimize the customer's experience in real time based on analytics like on their clickstream in your portal. A lot of cool stuff you can do. So really, big data enables you to speed answers to a wider range of business problems that often involve a lot of heavy-hitting statistical and mathematical multivariable analysis. Everything I've got in that list there, those 4 bullets there, is the core of what data scientists do day in and day out. So to enable deeply interactive and exploratory fact-based analysis of just huge gobs of data coming in remorselessly from everywhere. So essentially using statistical analysis, data mining and the like to do what are called real-world experiments. You can build a predictive model, a churn model, or a propensity model, and then test it out inside of your applications to determine whether it actually fits users' behavior, and then go change the model later on if it didn't fit with the actual observations. That's pretty powerful. Real-time, real-world experiments are what data scientists do for a living in a commercial setting. So big data, driving innovation everywhere. You can address global challenges. You can address business challenges. And these are the applications of big data, staying afloat, doing more with less, flexing and adjusting, and staying ahead, differentiating from the competition. It makes you smarter, big data. Information power, more information, plus the horsepower to crunch through it all, whether it be a data warehouse or a Hadoop cluster or maybe LexisNexis HPCC. There's a lot of different approaches for doing it, but fundamentally it's all about helping us, human beings, to make better decisions and really to help data scientists to do what they do even more powerfully because they've got strong tools that help with your BI and advanced analytics and are really helping you on all levels of your company to make better decisions from even the tiniest insights because small insights can move mountains when they're delivered at the right time to the right people. So big data, driving small insights, that's what it's all about, or could be, and should be. So at Forrester, we've done a recent survey, and we found of IT professionals, many have big data initiatives. A lot of them are in the eval stage. They're still trying to get their arms around the approach. Many of the big data initiatives that we're seeing are actually involving customer relationship management and ERP applications. On the front end, marketing, sales, customer service. On the back end, things like operations and logistics. So big data spans many different areas, many different subject domains of data. A lot of transactional data is used in big data environments, but a fair amount of machine and sensor data and social media. So fundamentally, big data just makes you smarter, gives you faster answers, gives you a single view of all relevant data. Hopefully it's high quality data before it's been loaded into your warehouse or cluster, Hadoop cluster, and that you can explore as you wish, Hopefully your big data environment's extremely scalable out to the petabytes and so forth. Hopefully it's extremely flexible. More and more of what we're seeing in big data is storage and in-memory and cache and so forth, put together as a unified infrastructure that's executing in parallel many new, very sophisticated types of models and algorithms developed by your data scientists. And hopefully you're doing it in a way that's affordable, reducing the cost of running your big data environment by having cheap storage, for example, underlying your data warehouse that should have massively parallel processing. Or maybe you're doing something very similar in a Hadoop cluster. There's different ways to skin this cat. But it can be a big frustration. Like I said, big data can be a big mess. Bewildering, slow, fragmented, messy, low-quality data in the cloud. That's not an asset. It's a burden. So really, you want to cut through all that. Don't overload me with data. Just give me fast answers to my business questions. So big data. The scale of big data is moving into the petabytes fairly rapidly, though most data warehouses in the real world are under 10 terabytes. We see at Forrester, we see a fair amount of growth in the last few years in the number of petabyte scalable data warehouses being deployed in various industries like finance and telecom and in government and so forth. And that's a never-ending process that's going to continue to grow. So we're seeing a heck of a amount of requirement for scalability in their underlying architecture. We're seeing a requirement for flexibility in terms of deploying this technology into the cloud. And we're seeing the cost of deploying big data platforms getting cheaper and cheaper. We're in the middle of a price war. Storage. Storage costs are one of the predominant costs in any big data initiative. We did some recent research, Forrester, and what we found was that the storage footprint in your IT budget is growing and growing. And in fact, the amount of data you're storing continues to grow. These were 5 years. We published this last year. That the amount of structured and unstructured data, both in production environments and in backup, continues to grow, and in fact is doubling every 18 months in many companies. 18 months doubling, that's essentially the same rate as Moore's law on the processor side. That's phenomenal. So that really represents, over the rest of this decade, 30 to 40 times growth in the amount of data you're going to have to store and manage, so that we predict that by the end of this decade, the average large enterprise will manage at least 40 petabytes of stored data. That's massive, and that's expensive. In fact, what we've seen, let me just build through this, is that recently we saw that there was, from 2007 to 2009, the average cost of storage in an enterprise's IT budget grew from 10% to 17% of the budget. And that's not stopping. We're seeing 20 to 40% yearly growth in storage budgets in many companies. But IT budgets as a whole, we're finding, are only growing around 5% a year, and our economy is still soft. So what that means is, if you don't make your data small real soon, compact it, your storage costs are going to max out. They're going to be 100% of your IT costs if you don't watch out. So what's to save us from this dire predicament? Storage costs need to drop, and we all need to leverage the best practices that exist for managing storage, managing data in the cheapest, smallest storage footprint we possibly can. So there are established best practices, and I'm the data warehousing analyst at Forrester, so what I'm about to present are not radically different from what data warehousing professionals have been doing for a long time. But now you need to apply them to your big data initiatives, whatever platform you happen to use. Make your data as compact as possible. Reduce the storage footprint both as a square footage in your data center and as a chunk of your IT budget. So really what you need to do is you need to focus. I'm just going to list these. Things like outsourcing of storage to highly cost-effective providers in the cloud. Make more use of high-density storage, storage-efficient database architectures like columnar databases, commodity storage drives, ever cheaper, and capabilities that many of your data warehousing vendors provide, for example, like continuously optimized placement of data on the cheapest disk. There's many different approaches, including efficient deduplication and compression of the data, to help you store more data more cost-effectively. But secondly, there's make the data as compact as possible, but also make it as consumable as possible. Deliver intelligence faster downstream to all decision makers in every business process, through your business intelligence environment, through to all the mobile devices and desktops you have. So make your data as consumable as possible. What that means fundamentally going forward is that in your business intelligence environment, you need to look for new ways to leverage big data and really personalize and target the delivery of subsets of that data and analytics downstream to the right people and applications to help them make decisions on the best data in real time. There's a lot of different approaches for making data consumable. Cloud analytics enables you to scale up or spin up a BI or an advanced analytics environment by using an SaaS provider. There's a lot of frontiers in business intelligence like self-service and in-memory and predictive and in-database analytics that really help you to make decision support tools and visualizations available ubiquitously everywhere throughout your company, in the field, in real time, and also to bring things like social sharing of all that intelligence. That's another way of making it as consumable, the intelligence, as possible. Personalize the delivery of it. Things like in data warehousing, like organizing your data sets in terms of subject areas like customer data and finance data and HR, and have them conform with common dimensions and schemas. Very important to help you quickly find the data you need, the latest and greatest reference data you need to make a decision on. There's a lot of other things like search technology that are also important in this light. And so really, that's how you make your big data as small as possible, and how you deliver it to more people and more applications to make your organization as smart as possible. So future trends. This cost of storage is coming down radically. And it's not just this decade. It's been going on since the dawn of computing. And so as I was thinking through several months ago, my talk today, I did some extrapolation based on various data points, some of them Forrester, one of them external. And I thought, wait a second, keep it small, stupid. Actually, storage is getting really cheap. And in fact, last year, an article was published by Vint Cerf, who, if you follow this industry, he's often regarded as the father of the internet. At least he's one of the prime movers in the internet, and he's a vice president now with Google. You almost can't lose your job as an analyst by citing Vint Cerf. He's unimpeachable. But this is also great research. Last year, he showed that retail, a petabyte of data costs roughly around $80,000 if you look at $120 per 1.5 terabyte hard drive retail. I thought, $80,000 per petabyte, that's a lot of money, but Then he said in the same article, based on historical trends, the cost of storage could come down anywhere between 10 to 1 and 100 to 1 in this decade by 2020. And I thought, okay, I'll take Vint at the 100 to 1. I'll be a bit optimistic on this side. I thought, if storage costs drop by a factor of 100 to 1 by the year 2020, and if data deduplication rates, if we can still realize a 20 to 1 dedupe ratio on structured data in storage, and deduping is simply reflecting the fact that a lot of data you store, say, in your CRM system or ERP system database, is redundant in terms of the values and so forth of the data. So a lot of it can be crunched down to for a much tighter representation of the core data without losing any information. And if you achieve a 10 to 1 compression ratio, which we're seeing more and more of in the market, for example, Oracle with Exadata is able to achieve that in some data sets. If you take all these assumptions and you say by the end of the decade, if this all applies, then conceivably a petabyte of data by the end of this decade of usable data storage can be $4. I had to keep on recalculating that and to make double sure that that wasn't an illusion. $4 for a petabyte. You know what that means is that by essentially the end of this decade, petabytes will be in the palm of everybody's hand. Because what that will mean is that essentially, here's a cloud, and there's a little device in it. And in summary, by the end of the decade, people throughout the world of every socioeconomic class will be able to fit cost-effectively onto their iPhones, iPads, every mass market or consumer device, an amount of data that's equal to more than 100 times the size of your enterprise's current data warehouse. More than 100 times, because the average data warehouse, even in a large company, is rarely much more than, say, 10 terabytes. So, cost of storage is the prime gating factor on the size of the platform that you use for big data. As storage costs come down, we're not going to see just petabyte scalable data warehouses. We're going to see the next order of magnitude, I guess several orders out of zettabyte or whatever it is. That's astounding. What that means is that by the end of this decade, we'll all have on-demand, seamless, continuous access to advanced intelligence on a scale that even the largest government agencies, well, only they can afford or manage or justify today. That is fundamentally going to change the way we all live and work. Big data will be small and cost-effective and will be everywhere. So that will just that'll revolutionize life as we know it. Thank you very much.
I'm afraid we don't really have time for any Q&A, but I know Jim will be around afterwards if you'd like to speak to him.
Jim has to run to the airport, but Jim has an email address, and you're all encouraged to email me, and I'll be glad. I'm also on Twitter, @James Kobielus.
Great. Thank you so much.
Sure. Pleasure to be here.